Welcome to the Walton Pi. Today we are going to be talking about the Euclidean algorithm, what it is and how to use it. So, the Euclidean algorithm is a way to be able to find the greatest common divisor of any two numbers, a and b. Anytime we're doing this, we're going to just assume that a is going to be bigger than or equal to b. So we start by dividing a by b. So if a was 537 and b was 63, a divided by b is going to be a little bit more than 8.5. So we're going to keep the integer part 8 and then drop the. So the 8 is going to be the value of q, so our quotient piece, so what we get when we divide it out. We're then going to determine what the remainder is, and so that's going to be a minus b times q. So if you think back to doing long division when you were younger, we are going to have the q be what we get when we divide, and then we have our remainder piece, and that's going to be called r. And the remainder should always be between 0 and b. If the remainder is 0, b is going to be the greatest common divisor of a and b, because b divided into a. But if the remainder is not 0, then we're going to repeat this process with a new value of a, which is our old b value, and then a new value of b, which is our current remainder r. So let's go through an example together. So let's try and find the greatest common divisor of 14,574 and 3,374. So to start off, we are going to say that a is 14,574 and b is 3,374. So our goal is to find values where we can write 14,574 is equal to something times 3,374, some remainder. So if we go through the process and figure out what those numbers are, we find that it's equal to 4 times 3374 plus 1078. At this point, we are going to now repeat the process because we didn't get a remainder of 0. So we are now going to have our new value of a be 3,374, and our new value of b is the 1078. So when we put those into the next line, we get this. We get that 3374 is equal to 3 times 1078 plus 140. And then we're going to repeat the process with a equals 1078 and b equals 140. And we're just going to continue to repeat this process until we get a remainder of 0. So 1078 is 7 times 140 plus 98. So we repeat with a equals 140 and b equals 98. And then 140 is 1 times 98 plus 42. 98 is 2 times 42 plus 14. And then 42 is 3 times 14 plus 0. As soon as we get the remainder of 0, we look at the remainder that we got right before that. So in this case, 14. And that is going to be a common divisor. So the greatest common divisor, 14,574 and 3,374, is 14. 14 divides both of these, and that is the largest number that divides both. So another question might be, is it possible to write the greatest common divisor in terms of x, or in terms of a and b? And it turns out that that is always going to be true. If we're careful in how we solved for the GCD using the Euclidean algorithm, it's always going to be possible to use that to help us write the GCD as a linear combination of a and b. So we can write d equals ax plus by, where x and y are some integers. So let's go through the process to figure the values of x and y out for the example we just went through. So here is our process written down one more time. And we are going to try and write 14 in terms of 14,574 and 3,374. So to start off, we are going to turn each of these into an equation that's just a little bit easier to work with. Basically, we are going to solve for the remainders. So we can get 14 equals 98 minus 2 times 42, 42 equals 140 minus 1 times 98, and so on. And then we are going to be working from the bottom up. so that we will be substituting in previous remainders into the equations to get simpler problems. So if we start by just looking at 14 is equal to 98 minus 2 times 42. We've now used all the information in the bottom row, which means that we don't really need it anymore. So we can now remove that since we've taken that into account and only look at the next line. So we figure out how can we use this next line to help us expand out what 14 is equal to. Well, we have 42 is equal to 140 minus 98. We're going to substitute that in everywhere there is a 42. So when we do that, we get 14 is equal to 98 minus 2 times the expression equal to 42, which can then simplify 3 times 98 minus 2 times 140. We've now used the line at the bottom, so we don't need it anymore, so we can remove it and we can continue this process. So we now have 14 is equal to 3 times 98 minus 140. So we used the line that says 98 is equal to 1078 minus 7 times 140. We plug that in and we just repeat this process. So now we have 14 in terms of 1078 and 140. So we don't need the line with 98 anymore. And we just are going to repeat this process over and over. Eventually are able to get back all the way to our starting point with our very first numbers. So we are able to find that 14 is equal to 72 times 14,574 minus 311 times 3,374. Now, we might wonder, why would we ever care about writing a number this way? It turns out that this is very useful when we are trying to find multiplicative inverses when we are doing modular arithmetic. If you would like to see that, there should be a video in the card that you can be able to click and be able to see a little bit more information about that. But that is a property that always will hold. Now, an interesting fact is it's only multiples of the greatest common divisor that can ever be written this way, where you can write it in terms of some constant times a plus some constant times b. Give a shot of trying to prove that to figure out why that's going to be the case, but that is going to be the case. So 14 being the greatest common divisor here is the smallest number that can be written this way. So we can't write 12 in terms of 14,574 and 3,374. But we can also write 28 this way by just doubling the coefficients in front of 14,574 and 3,374. By doubling those, we get like 144 of the 14,001 and a minus 622 of the 3,374. We can get 28. So we can get multiples of the greatest common divisor, but we can't get anything that's not a multiple. I hope this video was helpful in understanding the Euclidean algorithm. Please check out some of my other videos and like and subscribe. It helps me out quite a bit to be able to continue making these videos. Have a great day and good luck with the rest of your math.